This is 7.4. Sorry about the last video. My memory was filling up, and so I finally figured out how to permanently delete everything that I've been sending to trash. So now my memory on my phone is up to par. So anyway, all right. So we were talking about the difference of two squares, and now look at number 2 and 3. These aren't the difference of two squares, but one of these is, you are able to factor one of them and the other one you're not. So let's look at this first one. So 16 is a perfect square, so is x squared. And 1's a perfect square. So we're going to go ahead and split up those square roots and see if we can get a positive 8. So the square root of 16 is 4. Square root of x is squared is x. Square root of 1 is 1. All right, so this says that the two numbers are going to have the same sign, and the signs are positive. So let's see if this will get us back to this. So 4x times 4x is 16x squared. 4x times 1 is 4x. 4x times 1 is 4x. And 1 times 1 is 1. Now, if we simplify those two middle terms, we get 8x. So this, it does factor. And so that's the answer. So always double check it. Once you have two binomials, go ahead and multiply and FOIL them together and make sure you can get back to your original problem. Now, number 3, the first thing I notice is that these are both even numbers, which means that I can pull out a 2 from both of those terms. So I'm going to divide both terms by 2. All right, so if I wrote this the ABC way, this is letter A, B, there isn't a singular x here, so that would be like the middle term is 0. So there is nothing I can do with this right here. So if I go, okay, well, that's 8. So I can try, just from trial and error, I can go, well, I know that 4 times 2 is 8. And the only factors of 13 are 13 and 1. But there's no way I could do this so that I could multiply two positive terms and end up with a 0. So there's nothing I can do here. Even though I tried something, I could FOIL this, I would definitely not get back to this. So number 3 is not factorable. You can try splitting it up, but basically if it doesn't go along with the pattern that we've been talking about, the difference of two squares, or a trinomial, if you can split up a trinomial this way, if you have a perfect square and a perfect square and you want to split them up and see if you get this, go ahead and try it. But if you see a problem like number 13, and that's from my Hawks, then it's not factorable. All right, so let's look at a few procedures. So when we're factoring binomials or trinomials, we're always looking for a common factor we can pull out, divide everything by the same factor. Then you're going to check the number of terms. If you have two terms, you want to see, okay, are those two perfect squares, and is there a minus sign between them? If you have two perfect squares with a minus sign in between them, it is factorable. If you have two perfect squares with an addition sign between them, it's not factorable. Not factorable. For example, if you have x squared plus 16, that's two perfect squares. 4 times 4 is 16. X times x is x squared. But there's no way you can factor this so that the middle term is 0. So this is not factorable. However, if you have two perfect squares with a minus in between them, it is factorable. One's going to be plus 4, and the other one's going to be minus 4. Okay, this is factorable. Difference of two perfect squares. This is not. The sum of two perfect squares is not factorable. Now, the other thing we're going to look at is when we have the difference of two squares. Oh, sorry, that's what this is right here. Now, if you have a perfect square trinomial, for example, if you have x plus 5 squared, the whole thing squared, or x plus 2 squared, or x plus 3 squared, or a perfect square trinomial that has a subtraction sign between them. So x minus 4 squared, x minus 3 squared. It's always going to come out in this same pattern, okay? And so we're gonna be looking at this, and I'm gonna be doing some problems, and I'm gonna show you how it relates back to this. Okay, this is a pattern. This is something that's been proved over and over, and I will show you exactly what that means. All right, so summary of procedures to follow in factoring polynomials. If there's 3 terms, you're going to say, okay, is this a perfect square trinomial? Are we going to try the trial and error method, like number 3 right here? We tried dividing up that 8 and that 13, but we found out that that was not factorable. If there's 4 terms, you're always going to group those. You're going to put 2 parentheses around the 4 terms and pull out any common monomials. All right, so the first thing we're going to look at is completing the square. So we're going to complete the square as indicated. So which one of these problems right here does this look like right there? So we have y squared plus a number. It looks like this one, right? We've got 2 plus signs. So basically, it's telling us how to get, we want to know what is this missing term and what would this look like before it was factored. Okay? So basically, whatever number this is, if you're given the middle number, you're going to think that you're going to half it, because this is going to be twice what a is. This is twice a. Well, 20 is twice 10, right? And then you're going to square. When you figure out what a is, you're going to square that number. So if a is 10, I'm going to square 10 in my head. 10 times 10 is 100. And that's what goes right here. We're going to write x plus 10. Okay? Now let me show you how this equals this. This is x plus 10. So if I have x plus 10 squared, that basically means x plus 10 plus x plus 10. X plus 10 times x plus 10. So if I FOIL this, x times x is x squared. X times 10 is 10x plus x times 10 is 10x, and 10 times 10 is 100. So I get x squared plus 20x plus 100. So these are equivalent now. Okay, now that was just, I know that was confusing. I didn't explain that very well, but we're going to look at more. All right, so let's look at letter B. So this looks like this one right here. We have a minus and a plus. So the way we get A is the middle term has been doubled. So 10 is double what number? Well, 10 is double 5. So A is going to be 5. If you have one minus sign, the sign here is a minus sign. Well, then if I square negative 5, what do I get? I get 25. Okay, so if I FOIL this, x minus 5 squared, I'm going to get this right here, because I get x squared minus 5x plus 25, which equals this right here. Okay, so in order to find out what A is, you're going to half this number. So what's half of 6? The number's 3. If this is a plus, this is a plus. And then to get your blank here, you're going to square what you found out A was. So 3 squared is 9. Okay, so if you have the middle term, to get what goes inside this blank here, you half this number. So half of 6 is 3. And then to get this missing number, you square 3. So to get this missing term right here, we halved 10. We got 5. And then to find out this number or this letter C right here, we square that number. And that's how we're going to do these. All right, these are just the same. So if we have plus here, we know plus goes here. If we have a minus here, we know a minus goes here. So we're going to half this number right here. What's half of 3? It's 1.5. And to get this number, we square 1.5. Well, 1.5, I'm typing it in on my calculator. 1.5 squared is 2.25. So we've just completed the square. All right, so that one's a little tricky. Let's make sure it works out. So we have x plus 1.5 times x plus 1.5. So we're foiling it. X times x is x squared. X times 1.5 is 1.5x plus 1.5x plus 1.5 times 1.5 is 2.25. We combine those two middle terms, we get 3. And we're right because that's what we started with. All right, so to get from here to here, what do we do with this number? We half it. So half of 5 is 2.5. And then to get from here to here, we square 2.5. Or think of it as negative 2.5. If you square negative 2.5, you're still going to get a positive number because a negative times a negative is a positive. So when I square 2.5, I get 6.25. Okay, so let's go over the pattern again. To get what's missing at the end here, we're going to half this number. So half of 3 is 1.5. And then to get this missing number, we square what we wrote here. To go from 5 here, we're going to half this number. Half of 5 is 2.5. And then when I square 2.5, I get 6.25. All right, now these are similar, but this time the missing symbol, the missing number is our middle term, okay? So we're going to do it the opposite way this time. So remember, if there's a plus here, a plus goes here. A plus is here. If a minus sign is here, a minus goes in the middle. All right, so now let's think about this. So to get from here to here, all we do is find the square root of this number. So the square root of 100 is 10. And then how does this number compare to this one? This number is half of this one. So I'm going to multiply 10 by 2, and I get 20. Okay, and then if I wrote this out and foiled it, I'd get here. I'd get the same thing. All right, so the relationship here to here, I find the square root of 25, and I get 5, because 5 times 5 is 25. And then from here to the middle term, I double this. How do I get this missing term right here? Square root of 81. Square root of 81 is 9. And then to get the missing term right there, I double 9, and I get 18. All right, so this is everything. This is this difference of two squares, and this is completing the square. So let's look at number 1, and you have these answers, so maybe you can go ahead and stop the recording. You can try these yourself and then check your answers. And then if you have questions, you can listen to my explanation. So number 1 is the difference of perfect squares. So I'm going to divide up my perfect squares. Square root of x squared is x. Square root of 16 is 4. Since this is a difference of two squares, one gets a positive, one gets a negative, and I'm done. All right, number 2. This is the difference of two squares. So the square root of 25 is 5. Square root of x squared is x. And since it's a minus sign, one gets a plus and one gets a minus, and I'm done. All right, number 3. I see that all 3 of these terms can be divided by 3. So I'm going to pull out a 3. 3y squared divided by 3 is 1y squared. 6y divided by 3 is 2y. And 3 divided by 3 is 1. All right, so I'm going to divvy up. Since this is a perfect square and this is a perfect square, I'm going to write their square roots here. Now this middle term is not 0, it's 2. So I'm going to go ahead and give them both pluses. And then to make sure, I'm going to FOIL this. Then when I use the distributive property, I go right back here. So I know this is the right answer. That is factorable. And then number 4, I see 2 perfect squares. They're asking me the difference of these perfect squares, which is factorable. So the square root of y to the 10th is y to the 5th, y to the 5th. Find the square root of 81, I get 9 and 9. Since it's asked the difference, one's a plus and one's a minus. All right, number 5, I have the last number missing. So the first thing I'm going to do is figure out what comes here at the end. Well, this is an x plus, so this is an x plus. So to get from here to here, I'm going to half this number. So half of 6 is 3. And then to go from here back to here, I'm going to square 3, and I get 9. All right, number 6, the middle number is missing. So I'm going to look at what letter C is called. This is called letter C. I'm going to, in order to find out what comes at the end here, I'm going to find the square root of 49, which is 7. And then to go back to the middle term, I'm going to double 7, and I get 14x. Uh-oh, did I forget my x's on the other ones? I sure did, you guys. Look, when I found the middle term on F, G, and H, it's not just 20, it should be 20x. Not just 10, it should be 10x. Because that middle term always has a variable. It shouldn't be 18, it should be 18x. So please go back and check those, okay? And on HOX, if you forget that variable, it's going to tell you your answer is not complete. All right, that's a hard section, but hopefully everybody will get it. We just got to get some practice on our belts. And let's just go ahead and take a break right there then.